નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી.
Standard 9th, Subject Science, Chapter 11, Work and Energy. Dear students, today we will discuss energy. So far you learned about work. What is work? Today we will see the energy. Energy means what? So life is impossible without energy. See, whatever you want to do the work, you need energy or we need energy. The demand for the energy is ever increasing. See, if the energy demand is day to day increasing, where do we get energy from? So, you will say from food. Yes, correct also. But the sun is the ultimate, the biggest natural source of energy is the sun. So, without sun, energy will not be. Okay. So, many of our energy sources are derived from the sun. We also get energy from the nuclei of atoms. Whenever we know that atoms contain nucleus, when we will split the atoms, then we will get the energy also. From the interior of the earth also we are getting energy, and tides. So from this also we are getting energy. So ultimately, what is meant by energy? So, dear students, the word energy is often used in our daily life. To day-to-day life, we are using the energy. But in the science, we give it a definite and precise meaning. Precise means correct, particular meaning. Let us consider some of the examples, try to understand the energy. For example, you know that when a fast moving cricket ball hits a stationary wicket, so you know that it's okay, suppose this is the stump. Okay, here stumps will be there, 3 stumps. Okay, so then you are hitting the ball, you are throwing the ball. Okay, ball comes and it will hit the stumps. So then the wicket will be thrown away. Okay, correct? Next one. Similarly, an object when raised to a certain height, okay, you have taken some stones, raise height up to the height, and leave that is, and get the capacity to raised object gets the capacity to do the work. So you must have seen that when I raised a hammer, okay, you have taken the hammer, okay, hammer falls on a nail, okay, when you falls or when you hit the nails placed on a piece of wood, it derives the nail into the wood, so that nail will go or pierce into the wood. So here also, due to the energy, it will happen. We also have observed children winding a toy. You know that toy car you are taking and you are winding. Okay, when the toy is placed on the floor, it starts moving due to the winding. So the stored energy here. And okay, so now we will take another example. When a balloon is filled with air, okay, you take a balloon and go on filled with air. So we press it, we notice the change in the shape. So you know that when you are pressing, then it changes the shape. As long as we press it gently, okay, then slowly it can come to its original position. Okay, go on, press it and leave the air, then it comes to the original position. If you press the balloon so hard, okay, when it is blown, if you press it hard, it can ever explode it, producing the blasting sound. Okay, in all these examples, the objects acquire means gain. The objects gain energy through the different means. So the energy is nothing but the capacity to do the work. The capacity to do the work is called as energy. Okay, got the idea now? So, an object having a capability to do the work is said to be or is said to possess energy. The object which does not work, so you know that the object which does the work, you know that when the object doing the work loses energy and on which the work is done, it gains energy. See, try to understand this. The object which does the work, which is doing the work, that automatically you know that the loses energy, and the object on which the work is done, So that is gains energy. How does an object with energy do the work? See, the question arises, how does an object with energy do the work? An object that possesses energy can exert a force on another object. Okay, see, one object is gaining energy and exert a force on another object. When this happens, it means what here? Energy is transferred from the former to the latter. Suppose here the object will be there and here object will be there. Okay, if you push here and this moves here and it will move here, so means energy is transferred from one object to the another. Thus, the first object had the capacity to do the work. This implies that any object that possesses energy can do the work. Okay, so means the energy possessed by an object is thus measured in terms of its capacity of doing the work. See, the energy is measured in terms of doing its capacity to do the work. The unit of work is joule. So what is given? The unit same as the work. Okay, it is the unit of work is joule. Therefore, the same as that of the work. It is denoted by J. Okay, it is denoted by J. And energy is a see now, sometimes a larger unit will be there, that is called as kilojoule. So this will be written kJ. What will be written? kJ. So okay, this is the larger unit. Means 1000 joule. Okay. So now try to understand this. Energy is scalar quantity. Scalar quantity. Okay. It has only a magnitude, but not direction will be not there. Now we'll discuss about forms of energy. There are various forms of energy, mechanical energy, including potential and kinetic energy, heat energy, light energy, chemical energy, okay, and electrical energy, and so on. These are all the forms of energy. Okay, got the idea now? So now, dear students, here one more important point to remember that James Prescott Joule. James Prescott Joule. He is a scientist. What the name is given, you see, James Prescott. Okay, Prescott. Prescott. Okay, Joule is given. So he is a scientist. James Prescott, Prescott, Joule, was an outstanding British physicist. He is a British physicist, British scientist. He is best known for his research on electricity and thermodynamics. So he is worked on the thermodynamics and as well as electricity. Among the other things, he formulated the law of heating effect of electric current. So this will come to the 10th standard. He also verified experimentally the law of conservation of energy and discovered the value of mechanical equivalent of heat. So, okay, so these are all his contribution to this field. The unit of energy and the work called joule. You know that the unit of energy is called joule is named after him. So that is why his name is James Prescott Joule. The unit of energy is given his name because he has contributed in thermodynamics and electricity as well as heating law of as well as heating effect of electric current. So that is why he has done the more contribution here. So that is why his name is given the unit of energy joule. Okay, named after him. Now we will discuss about the kinetic energy. There are two types of energy: potential energy as well as kinetic energy. So just first of all, we will discuss about the kinetic energy. So for example, here given the take an activity, we will discuss the activity. Take a heavy ball and drop it on a thick bench side. Okay, what you have to do here, heavy ball, make it lift and raise it. Raising the heavy ball, you have to lift it. Okay, take a heavy ball, lift it here and drop here. Here side bench will be there. Okay. And then wet bed of sand is better. Why? Because you can see the impression here. Drop the ball on the sand, bed, drop the ball from the or on the sand bed from the height of, okay, take about 25 centimeter. So what you will observe, dear students, you will observe that some depressions. Okay, some depression means khada, you are saying, no? Some depression you will observe. And repeat the activity again, take off different measurement, 50 centimeter, 1 meter and 1 point. So like this, different heights you have to observe it. So ensure that all the depressions are distinctly visible. So you must able to notice the depressions. Okay, make the depressions to indicate the height from which the ball was dropped. So what you have to do is, see, suppose this is a ball, and here you make it here write the measurement height. Then compare the depths. Compare the depths you have to. In which height? Okay, what you have raised the height and the object you have dropped, and where you will see the more depressions. More depressions where? So which is the deepest? So ultimately you know that which you have taken the highest height. So that shows the more depressions, and which has caused the small depressions. So that will be which is you have taken the low height. So that shows the what here small depressions. So correct. In the similar way, set up the other experiment like another activity like this. Place a wooden block now mass in front of the trolley. So like this activity is given in the textbook. Try to understand. See, here trolley will be there, here block will be there. Okay, then here will be mass of weight. So and here you have to put the weight, and this will lift, touch to this, then this will move here. Okay, like this. So a moving object, here what we are noticing, dear students, a moving object can do the work. From this you will come to know that the trolley moves forward and hits the wooden block, and then note down the displacement of the block. So this means that work is done on the block by the trolley. So that is okay. A moving object, from this you will come to know that a moving object can do the work. An object moving faster can do the more work. So which object will move faster? See, the work depends upon the speed of the object also. Okay. An identical object moving relatively slow. So if we are considered two objects, it's a similar object, but one is going slow and another one is going, okay, in another situation it will go very fast. So where it will move faster, there it will be more work. Okay, for example, a moving bullet, okay, blowing wind, a rotating wheel, a speeding stone. So these all can do the work. How does a bullet fear the target? You know that whenever the bullet is so fast, so that will fears us. It will hurt the person. How does the wind of the wind will be moves the blades of the windmill? So whenever strong wind comes, you know that the windmill, the blades will move faster. So objects in the motion possess the energy. Okay. So we call this is we are saying the kinetic energy. So what do you mean by kinetic energy? Kinetic energy is the energy possessed by an object due to its motion. So what is kinetic energy? The energy due to its motion, or the energy possessed by an object due to its motion. So that is called as a kinetic energy. For example, a falling coconut, a speeding car, a rolling stone, a flying aircraft, and flowing water, blowing wind, running athletics. So these are all examples you can give the kinetic energy. Okay, the kinetic energy of an object increases with its speed. See, the kinetic energy will be increasing with its speed. So whenever the kinetic energy, how it will increase, depends upon the speed. If the speed increases, the kinetic energy also increases. Okay, got the idea, students? And remaining things we'll discuss in the next video. Thank you. Bye-bye.
Thank you for joining us.